Good afternoon, everyone. Good afternoon, Akshara, Raghav, Aditya Jain, Rohan. Good afternoon, Shubhranshu. Good afternoon, Aditya Putricha. Good afternoon, Sunena ma'am. Good afternoon. So let the students join. In a minute, we are starting. Good afternoon, Navya, Mehdeep, Panchika Meglani, Chanvi, and all others present there. So we have started yesterday question number 4. So just write it down if you have not written this, given to prove and all. So we can start with the proving after this. Good afternoon, Manpreet, Nisha, and Lavanya. Very few students have given me the notebook. Okay, and rest of the students are advised to send the PDF form of the notebook. Okay, I have already messaged today in your homework. Yeah, Vineet, you are asking when you have to submit notebook. You can submit notebook today, now, tomorrow, this week. Just complete it so that I can check by Saturday or Sunday. Okay, question number 4, show that diagonals of a square are equal and bisect each other at right angles. So what is given in the question? That this is a square. ABCD is a square. ABCD is a square. So it is written here that ABCD is a square. After that, we need to prove that diagonals are equal. So AC and DB are equal. First of all, this will prove. Then they are bisecting each other, means AO is equal to OC and BO is equal to OD. So also we have to prove. And after that, we have to prove that they are bisecting at 90 degrees. See, there's many terms are written here: bisect, right angles, diagonals are equal. So 3 things we need to prove here. Okay, so angle 1, 2, 3, 4 all should be 90 degree because they should bisect at 90 degree. Okay, now So how we can prove that AC and DB are equals? For that we can take these full triangles where AC and BD are lying. Okay, so you can take one this triangle, this one, and one you can take the other one, this. So just take these two triangles and write what are given. Proof in triangles A, B, D and triangles A, B, C. In ABD and ABC we have AD is equal to BC. Why? Because all the sides of the square are equal. It is given, no, ABCD is a square. It's right here, sides of square. These are the sides of square. But we are doing right now chapter number 8. So at least send me your notebook till chapter number 7. Simple. So AD and BC are equal. And after that, AB is common in both the triangles. You can see AB is there in this triangle also and AB is there in this triangle also. So this is a common side. That's why AB of both the triangles are equal to each other. After that, angle A and angle B will be 90. So angle A of this triangle and angle B of this triangle will be equal to 90 degrees. So each 90 degree, because you can say here angles of square is equal to 90 degree. So by SAS we can say that triangle ABD is congruent to triangle ABC by SAS, and because of this congruence criteria, means because of this congruency, we can write that DB is equal to AC. DB of this triangle and AC of this triangle are equal to each other by CPCT. So first we have proved, see this was the first part, that we have to prove AC and DB are equal, and this we have proved. Fine, I have highlighted here for you that first we have proved here. Then AO, OC, BO, OD we have to make equal. So we have to take now those triangles in which AO, OB, BO, OD are present. Now AOOC, AOOC, BOOD. Then these two opposite triangles you can take. This triangle and this triangle. Take the triangles. I'm solving this side. That in triangle, just right now, in triangle AOD and triangle BOC. In triangle AOD and BOC, can we write the things which are equal? Do we have anything equal in these two triangles? One side and two angles. Two angles, okay. So I'm taking first of all AD and BC equal, because AD and BC are the sides of square. So sides of square are always equal, that we know. So AC and BD are equal. After that, now just look here. You can also write this. Mention here angle 1. Sorry, not angle 1. Angle 5, angle 6, angle 7, angle 8. Okay, now look here. 5 is equal to 6 and 7 is equal to 8. Because alternate interior angles. See, this Z is forming. There's a formation of Z. No, so 5 and 6 are equal and 7 and 8 are equal. After writing this, we can write here further that angle 5 is equal to angle 6 and angle 7 is equal to angle 8, being alternate interior angles. And same here, alternate. Some students are saying, sir, by AAS also we can do. Yes, you can. You are right. If you are taking vertical opposite here, then it is with the help of AAS we can prove. So alternate interior angles. So because of this, there are two angles and one side in between. So by ASA I have done. By ASA we can say that triangle AOD is congruent to triangle BOC. Okay, and afterwards we can say that AO is equals to OC and DO is equals to OB. So here comes the second part. This also is being proved by CBCT. So by ASA, I have proved that DO and OB and AO and OC are equal. How it is proved now? See this. Two triangles you have proved congruent, then AO will be equal to OC and DO will be equal to OB. Very simple. Because these are the parts of these congruent triangles. So it will be equal to each other by CPCT. After this, the question doesn't end here. We are left with the third part, where the between angles 1, 2, 3, 4, all these four angles we have to prove 90 degree. So how we can do that? Let me shift this figure here for you so that you can see it better. Now look, how we can prove that 1, 2, 3, 4 all are making 90? Take two adjacent triangles. Now I am taking this triangle and this triangle. Take these two triangles. In triangle AOB and BOC, and there is no one more way. See this. Look here, everyone. Okay. Now I have told you by congruency. There is one more way here. In place of this full congruency, no, just we can write 2, 3 lines and this will get prove equal. Okay, but now I have told you by congruency. Some other day I'll tell you the other method. Now AOB and BOC. Here no, AB is equal to BC. Sides of square. And AO is equal to OC. This we have proved above. It's right here, proved above. This we have proved no here in the second part. AO and OC are equal. So we can take this also, and OB is common in both the triangles. Therefore, triangle AOB is congruent to triangle BOC by which criteria? By triple S, we have proved this. And by CPCT, we can say that angle 3 of this and angle 2 of this are equal to each other. Then we can say that angle 3 and angle 2 together will make 180 degree because of linear pair. Is it possible that angle 3 and angle 2 will make linear? Yes, it falls on a straight line. So 3 and 2 together will make 180 degree. Mention all these angles which I have marked here: 1, 2, 3, 4, 5, 6, 7, 8. So 3 and 2 will make 180, and we can write both of them as 3 and 3 because 2 and 3, angle 2 and angle 3 are equal. We can write here that angle 3 and angle 2 are equal. So that's why we have written in place of 2 angle 3. Gurleen, where are you busy? Are you doing questions? Okay. Be attentive in the class. Okay, Kamalpreet. You should be in uniform. It's okay right now. Happy birthday to you. God bless you. The rule of the school is uniform. Okay, take care of that. Okay, 3 plus 3 is 180. Come back to the question. It is twice of angle 3 equals to 180 degree, and this way angle 3 will be equal to 180 divided by 2, and it is equal to 90 degree. So if 3 is 90, see this, if 3 is 90, then 1 will be 90 because vertical opposite angles, and if 3 is 90, then 2 is 90 because 2 and 3 are equal. Just look here that 3 is equal to 90, and here we have written that 3 and 2 are equal, so angle 2 is equal to angle 3 is equal to 90 degree, and angle 1 is equal to angle 3, and angle 2 is equal to angle 4, which is also equal to 90 by vertical opposite angles, so angle 1, angle 2, angle 3, and angle 4 all are equal to 90 degree, hence proved. So all the parts are over. Note it down. Those who are coming now after 15 minutes, attendance will not be marked. Milan 9 Florence, your screen is all black. Is it done? Okay, Devanshu, I know. Have you done this? Should I move to the next? So the next question is, okay, question number 5. Show that if the diagonals of quadrilateral are equal and bisect each other at right angles, you need to prove that it is a square. It is just a reverse question of the previous. Let us start the solution. Draw. As we have to prove it a square, so I am just making a square. Then marking it A, B, C, D, where I need to draw the diagonals also. Draw the diagonals. So this is a point O, where show that if the diagonals of quadrilateral are equal, diagonals are equal of a quadrilateral. So what is given? That ABCD is a quadrilateral where the diagonals are equal. So AC and DB are equal. And bisect each other means AO equals to OC and DO is equal to OB. So AO is equal to OC and DO is equal to OB. That is also given. After that, they are bisecting at 90 degree. It means these all 4 angles are making 90. So 1, 2, 3, 4, which we have proved now in the previous question. All those things are given here in given only. Means it is already given in the question. So these 3 things are given. First this, second this, and third this. AC is equal to DB, AOC, DOB are equal, and all the angles in between they are equal to 90 degree. Then what we need to prove? To prove ABCD is a square, to prove ABCD is a square. So how we can prove it is a square? Yesterday I've told you a criteria process. If in a figure, if in a question quadrilateral is given, then first of all we have to prove the quadrilateral as a parallelogram. Then after proving it a parallelogram, we'll prove it a square. Okay. So trying to proving it, first of all you should try to prove it a parallelogram. Anything is given so that we can directly write that it is a parallelogram by the help of the theorem. Now see this. Let's read it out. AO is equal to OC and DO is equal to OB. It means diagonals are bisecting each other. Since diagonals of quadrilateral are bisecting each other, therefore ABCD is a, I have told you the property of parallelogram that if in a parallelogram diagonals bisect each other, and if in a quadrilateral diagonals are bisecting each other, it means it is a parallelogram. Since diagonals of quadrilateral are bisecting each other, you can even mention here that how, because AO and OC are given equal and BO and OD are given equal. These things are given equal, DO, OB, AO, OC. That's why ABCD is a parallelogram. So it is proved a parallelogram. It means opposite sides are equal in parallel now. We can say that the opposite sides are equal and opposite sides are parallel. Okay. Now we can prove further. How we can prove it a square? By proving all the sides equal. Fine. And by proving any one angle 90 degree. First of all, I am proving all the sides equal. So taking these two triangles. I have told you in the question of rhombus that if it is a parallelogram and you prove one pair of adjacent sides equal, it means all the sides will become automatically equal to each other. So that's why I am taking these adjacent triangles. Take in triangle COD and triangle BOC. Right? CD and BC, are they equal? No. OC is common in both. We'll write OC is equal to OC, common. After that, angle 3 and angle 2 are equal because both are 90 degree. It is already given. We have written here. Angle 3 and angle 2 each 90 degree. It is given in the question. And after that, DO and OB are equal. And this is also given in the question. Therefore, triangle COD is congruent to triangle BOC by SAS. And if it is proved by SAS, then we can say that CD side is equal to side BC. Look here, this CD is equal to BC by CPCT. Is it clear? So because of this, we can say that no need to say anything. Okay, just leave it here. Further, we can write ABCD is a parallelogram with one pair of adjacent sides equal. If in a parallelogram one pair of adjacent sides is equal, then all sides are equal. Therefore, AB is equal to BC is equal to CD is equal to DA. Is it done? Now, after proving all the sides equal, we can say that it is a rhombus, but we can't say that it is a square, because for square, no, we need one more thing. We can say it we can't say it a rhombus also because the diagonals are also equal. Okay, so let us prove that any one angle of this is 90. Okay. Okay. So how to prove that the angle of this quadrilateral is 90 degree? So we can take two triangles. Now I am taking the triangle this and a triangle this ACD and BCD. And triangle ADC and triangle BDC. Yesterday I have told you this chapter require a lot of practice, then only you can understand. So in ADC and BDC, we can say that now what are the things equal? AD and BC are equal because we have proved here, proved above, just right here, proved above. We have proved no, all sides are equal in this, and after that CD and CD is common. Again after that BD and AC means AC and BD are AC and DB are equal. This is given in the question, and therefore triangle ADC is congruent to triangle BDC by triple S criteria, and by CBCD we can say that angle D is equal to angle C. If D and C are equal by CPCD, we can say that angle D plus angle C will make 180 degree because of co-interior angles. Again, this concept has been repeated again and again. Co-interior angles. Now D and C are equal, so we can write D plus D equals to 180 degree. Now twice of angle D equals to 180 degree, and angle D is equal to 90. Now again you have to write a statement to end the question. ABCD is a parallelogram with all sides equal and one angle 90 degree, all sides equal and one angle 90. So, and we can write here the diagonals are also equal, but just leave. This is also satisfactory. ABCD is a parallelogram with all sides equal and one angle 90. Therefore, ABCD is a square. Complete the proving, complete this part. We need to do one more question after this. I'm giving you 1 minute to note it down. Keshav, Sneh, Veer Devender, Sukhman, Lavanya Mittal, Kamalpreet, okay, has told me. Then Milan, Ajay, Gaganpreet, Preet Tyagi, Kashvi, Vadita, Sukhjeet, Rohan, Ranveer, Kavya, Ishita, Kunal, Nivek, Yuvraj, Manpreet, whatever, these all are without video and taking classes. Done. Okay. So moving on to the next, which is question number 6. In question 6, no, diagonal AC of a parallelogram. It is given that ABCD is a parallelogram. So I am making here this same figure again. A, B, C, D is a parallelogram where the diagonal is A diagonal is drawn AC, and we can say here that look here, diagonal AC of a parallelogram ABCD. This is a parallelogram ABCD and AC is the diagonal. It bisects angle A. Means angle A is divided into two equal parts by the line AC. Means this diagonal AC is dividing this angle into two equal parts. So let it be angle 1 and let it be angle 2. So angle 1 and angle 2 are given equal. So what is given in the question? Right, first of all, ABCD is a parallelogram where AC bisects angle A. It means angle 1 and angle 2 are given equal. Now what is required to prove? First, you have to prove that, right, first proving is AC bisects angle C. Look here in the question, it is written that AC bisects angle A. We have to show that it bisects angle C also. Means AC bisects angle C also. It means angle 3 and angle 4 should also be equal. This we have to prove here. Angle 1 and angle 2 are given equal. Angle 3 and angle 4 we have to prove equal. Then second part, ABCD is a rhombus. Now proof. So how we can prove this? That AC bisects this also. Okay, starting with the proving part. As it is a parallelogram, so we can say that opposite sides are parallel. So this and this and this and this are parallel to each other and they are equal also. So which criteria we can use? First of all, write here that angle 1 and angle 2 are equal. Angle 1 and angle 2 are equal. In the same way, we can say we have to prove that angle 3 and 4 are also equal. Look here, angle 1 is equal to angle 2. This is already given. It is already given in the question. See this, here we have explained this, that AC is bisecting angle A, so angle 1 and angle 2 are equal. Now I am writing that angle 1 is equal to angle 4 also. Alternate interior angles. And I can write that 2 is equal to 3 because of alternate interior angles. Yes, no, and further you can explain that 1 is equal to 4 because AD and BC are parallel. And here also you can add this reason also in between. And how they are making alternate? Because CD and AB and DC are also parallel. Because of this, alternate interior angles are possible. Alternate interior angles are possible only when there is the presence of parallel lines. So 1 and 4 are possible with the help of AD and BC. And 2 and 3 are possible only with the help of this Z. And this Z includes DC and AB. So I have written this, DC and AB are parallel. Now if, let me take this as equation 1, 2 and 3. Just write here from equation first, second and third. Now look at one thing. Angle 1 is equal to angle 4. Angle 2 is equal to angle 3. And angle 1 and 2 are equal to each other. Angle 1 and angle 2 are equal from the first equation. So therefore angle 4 and angle 3 will also be equal to each other. Is it clear? Suppose angle 1 and angle 2 are equal and both are 60 degree. Then here also it will be 60. If this is 60, then this is also 60. And angle 2 is 60. If this is 60, then this is also 60. It means all these angles are equal to each other. Very simple. So from first, second and third, we can say that angle 3 is equal to angle 4. If 3 and 4 are equal, so our first equation, meaning this first proving is proved. See, AC, we can write that AC is bisecting angle C also. Therefore, AC bisects angle C because 3 and 4 are equal to each other. Now, how we can prove that this is a rhombus? It is also very easy. Now, see this. Take first equation and second equation. 1 and 4 are equal, and then 2 and 4. See this. From equation 1 and 2. See, in this question, this is very easy question. Just you have to make these three equations, one given, one alternate, and third also alternate. And with the help of these three equations only, we have to prove it again and again. For example, the first we have proved from three equations. Now, second we are going to prove from the first two equations. See, angle 1 is equal to angle 2, then angle 1 is only equal to angle 4. Means 2 and 4, angle 2 and angle 4 are equal to angle 1 only. It means 2 and 4 are equal to each other. From first and second equation, we get to know that angle 2 is equal to angle 4. Now see in this triangle, angle 2 is equal to angle 4. It means this side will be equal to this side. Sides opposite to equal angles are always equal. If 2 and 4 are equal, therefore we can write here that BC is equal to AB. Sides opposite to equal angles. Now, why I have proved the adjacent pair of side equal to prove it a rhombus. Just right now, ABCD is a parallelogram whose one pair of adjacent sides is equal. Therefore, ABCD can be considered as a rhombus. Okay, the most means you can say the very near or the most probable figure here will be rhombus only if we are proving all the sides equal. Because now, if in a parallelogram you are proving only the sides equal, we can say that it is a rhombus. And if you are proving angle ABCD also 90, then it can be a square. Okay. So for square, much more things are required, and for rhombus only sides should be equal. So this way we can prove it as a rhombus. Note it down, and rest of the question we are going to do tomorrow. This exercise, again I am saying that it will take time. This week we are going to just spend our time in this exercise. We have today means it's Wednesday. And 2 more days. Bye, take care. We have a minute left. You can note it down by the time. Don't forget to complete your work. Friends, complete your work and send Prince 9th Blossom. Okay? Okay, bye. Take care.